Today we're going to demonstrate how to use the method of completing the square to solve quadratic equations. This is a method that always works, and it relies on fudging with the first two terms of a quadratic, the quadratic and linear terms, so that you can get something you can eventually factor into a perfect square trinomial. So we'll demonstrate this with this first problem here. We want to solve y squared plus 8y plus 1 equals 0. So the first step in completing the square, we're going to go ahead and write this out so that we're ready to introduce a new term here. So I'll write some parentheses here, y squared plus 8y, and I'm going to leave a space here for something that we'll add later, and then we'll have the extra 1 left over. And of course, this is set equal to 0. Now the key for completing the square is to look at your linear term, the term that is attached to x, look at that coefficient, take half of it, and then square it. And then to preserve the equality, we'll need to add it on both sides. So what will go in this space here, we will look at our linear term, in this case that's 8y, take that coefficient and divide it by 2, and then we'll square it. So 8 divided by 2 is 4, and 4 squared is 16. So we'll put a 16 here on this side, inside the parentheses, and then we'll also add 16 on this side. That way we've added 16 to both sides, so we preserve the equality. So we have y squared plus 8y plus 16 plus the leftover 1 on the outside, and then we have the equal 16 here. We added that to both sides. Now we can factor this bit in the parentheses using our perfect square trinomial formula. This is y plus 4 squared. And I'm going to go ahead and subtract 1 from both sides, this outside 1 here. So this is set equal to 15. And now we'll take the square root of both sides, of course remembering the plus minus. So we have y plus 4 equals plus minus the square root of 15. And then to finish this off, we will subtract 4 on both sides. And so we are left with y equals minus 4 plus minus the square root of 15. Now, if you use the quadratic formula, you will eventually arrive at the same answer. Completing the square actually gets you the quadratic formula in general. So now we move on to our second one. We have 2z squared minus 3z minus 3 equals 0. Now, notice that the coefficient on z squared is not 1 as we had it here. So to begin, we need to make sure that we scale this appropriately. So we'll divide through by 2. So we are left with z squared minus 3 over 2z minus 3 over 2 equals 0. Now we just repeat the same process we've had here. I will actually go ahead and rewrite this again with the space. Z squared minus 3 over 2z plus something minus 3 over 2 equals 0. And the thing that goes in this space, we will look at our linear term again, take half of it and square it. So in this space, we have minus 3 over 2 times 1/2, that's the same thing, squared. So minus 3 over 2 times the half is minus 3 over 4. Square that, we get a positive 9 over 16. Remember that when you square something, you always get a positive number back. So we will add the 9 over 16 to this side here and on this side here. So we have z squared minus 3 over 2 plus 9 over 16 with the leftover 3 over 2 outside there, minus 3 over 2, equals 9 over 16. Now we will go ahead and add 3 over 2 to both sides and factor this. So this bit factors as z minus 3 over 4 squared. And now when we add 3 over 2 to that side, we get a common denominator. We'll have 9 plus 24 over 16. 9 plus 24 is 33 over 16. Now we take the square root on both sides. So this gives me z over minus 3 over 4 equals plus minus square root 33 over 4, because the square root of 16 is 4. And finally, we add 3/4 to both sides, and we arrive at z equals 3 plus minus square root 33 over 4. And now we have one more example here. We have minus 3w squared plus w minus 4 equals 0. And so one more time we will scale this so that the leading coefficient is 1. So we'll divide through by minus 3. This gives us w squared minus 1/3 w plus 4 over 3 equals 0. Now the same process, we'll take half of the linear term and square it. Okay, so this becomes w squared minus 1/3 w plus something, we'll figure that out in a second, plus 4 over 3 equals 0. And in this space, again, we will look at minus 1/3 times a half squared. A third times a half is a sixth, and minus 1/6 squared is 1 over 36. So let's go ahead and add that to both sides right now. So we have w squared minus 1/3 w plus 1 over 36 plus the leftover 4/3. And that equals 1 over 36. And now we factor this bit in the parentheses. We see that this is w squared minus a 6, w minus a sixth squared. And when we subtract this 4/3 over, we multiply top and bottom by 12, so that's going to be 41 minus 48 minus 47 over 36. And now we'll take the square root of both sides. On the left, we have w minus a sixth. That's going to be equal to, well, we have a negative here, so we're going to have to introduce complex numbers. So this is plus minus I times the square root of 47 over square root of 36 is 6. And now when I just add things over, my roots are 1 plus minus I square roots of 47 divided by 6. And completing the square, of course, a versatile tactic that always works, relies on fudging the first two just so you can get the perfect square trinomial.